Hi, this is Nathan Case. I am the AWS Security Geek for today. We're going to talk about threat response scenarios using Amazon GuardDuty, which is really cool. Today is going to be a pretty long discussion, 45 minutes, around what we can do with GuardDuty, what we can detect with GuardDuty, and what we're going to do with that detection once we find it. It's kind of an interesting thought. We typically talk about GuardDuty and we kind of stop there. And the reality is we need to start telling everyone what they should do once they find a threat and how they're going to respond to that threat. So we're going to talk about two today specifically, two pretty common ones, and we're going to give some pretty prescriptive guidance as to how you want to go around it. All right, so yeah, it's GuardDuty. I'm going to do a quick intro. We have to kind of do that. It is the way it works. We've all seen this slide, I'm pretty sure. GuardDuty helps security professionals quickly find threats. I'm not going to read the rest of it. The real key word here to remember is that we're quickly going to find threats. We're looking for behavior, right? We're looking for things that will allow us to know that something bad is happening in our environment. Now, when we talk about something bad happening in the environment, we're talking about something that's happening in the VPC flow logs, in the DNS, or the CloudTrail events. Now, for everybody out there who's new to this, VPC flow logs basically means things that are happening between two instances or two ENIs, so elastic network interfaces. When one machine sends network traffic to another machine, it goes across an ENI. So if we talk about it, the VPC flow logs, we're really kind of talking about this infrastructure layer that you used to have with switches. So Cisco guys, this is totally where you're at. DNS logs. DNS logs are exactly what they seem to be here. Keep in mind that these are VPC DNS logs, not necessarily your AD logs. They are specifically instance requests for the DNS at the VPC level. So if someone gets malware, if an instance gets malware, it's going to make a request to go back to a command and control server. And because it's making that DNS request, it's trying to find out that name server, the dynamic name server. It's going to go ahead and register in GuardDuty as a threat because it shouldn't be asking for command and control domains. And CloudTrail is kind of the odd man out here. CloudTrail talks about things that happen inside of your account. So it's talking about the API calls that exist and that have just been made and by who they've been made. Now, as we start off, GuardDuty starts off very straightforward. It's using definitions just like many other systems in the world. As things go forward, though, we start looking at threats intelligently. So we're going to start trying to figure out what's happening. After that first 30-ish days, we're going to start using machine learning to figure out what's abnormal. So if someone starts doing something that's not normal from a Tor exit node, certainly that would be caught day one. We would expect someone doing an API call from a Tor exit node to be brought up as a threat, certainly, absolutely, 100%. But something happening from an abnormal behavior takes a little bit of time for the system to learn. And after that 30-ish days, you should start seeing those behavioral threats. Now, what we're going to talk about today is really kind of this last little window here, this take action, right? Because we totally want to do something about it once we find out that there is a threat in our system. Now, what does GuardDuty find? So this is the general list of things that GuardDuty finds. Today, we're going to talk about cryptocurrency and command and control, okay? So we're really looking at that third item there, but I want you to look at the other ones here as well. There's some other interesting things here. We have some unauthorized access, suspicious activity, a little bit of pen test in there, pretty much bad things. I mean, if you read this list, generally as a security professional, you're thinking bad things are happening. The other thing I want you to think about as we start going through this, we need to understand the different domains that people can attack. So we're going to talk about infrastructure, right? We kind of talked about it a second ago. We're going to talk about things that function just like those old school data center switches, racks that you used to have, right? That's the infrastructure. So something that would be a switch, something that would catch a packet, that's infrastructure. Absolutely, that makes sense, right? Then we're going to talk about application. You've got to install something on that infrastructure, and that generally looks like this. I know that I've drawn these diagrams for years now, and it's really kind of what it is. I mean, it really hasn't changed a lot if you start looking at these diagrams. I mean, we still have a router, we still have a public subnet, we still have a private subnet. There's still a virtual machine sitting in there that we call them instances, right? And they all have different IP addresses and different IP subnets. It really kind of looks a lot the same. And this is really where a lot of the security professionals in the world kind of, they're used to this. This is bread and butter. This is normalcy, right? This is how we judge our security risk. Now, as we look at this, there's really kind of another thing here, right? We've got this services item here on the right. As we look at this, what is this? Well, this is kind of that thing that Amazon provides you that's extra. This is the different services that might be available to you if you were an AWS client. We've got Amazon S3. Everybody's always heard about Amazon S3 buckets and all of that. But we have some other really intricate services. I just put a few on the screen because they were kind of, random and very different. We've got RDS, which is our relational database service, and we've got KMS, which is an encryption service. IAM seems to be something that we should talk about here because realistically, that's one of the things that you're gonna have to deal with as a service layer risk, right? So service layer really comes down to, when we talk about this risk, right, we're talking about what happens when someone breaches one of these things. So if we have an S3 bucket that's been made public and we didn't mean to, what happens now? If we have an RDS instance that someone put in a public subnet, how did that happen and why did that happen? If someone has an IAM account and that account has been breached because someone's compromised credentials in that account, this is that service level domain. So as we start talking about this, that's one of the service levels that we need to talk about. Now, generally, when I'm giving this talk or portions of this talk at the lofts in San Francisco or New York, we talk about the other, and there's like, a couple hundred people in the audience, and we have 3 people up on stage, and someone's acting as infrastructure, someone's acting as services, and someone's acting as application. And I point to the audience and I say, hey, and you guys are the other, right? We are all the meat suits that are responsible for making the mistakes. We are the people who are causing the problems inside of your AWS account typically because we've screwed up. So what is GuardDuty going to help us do? GuardDuty is going to help us by using all 3 of these domains and the way we act as ways to detect threats inside of our domain. And with that, we look at the AWS Security Solutions Matrix, right? GuardDuty is totally a detective control. We sit nicely over here on the left, about halfway down, close to the bottom. We've already kind of talked a little bit about CloudTrail and how that's the APIs, right? That's what people do. That's what happens inside of your account. We've talked about VPC flow logs and how that's specifically the things that happen between 2 instances or services inside of AWS. Now, we don't see DNS logs here, but it would still be under detective controls there in the left, in the mid left. Now, if we look all the way over on the right, we see incident response, right? We see AWS Cloud config rules and we see Lambda. We see some interesting things here, right? How do we deal with this? Well, we've got all these things over here at the far left, right? We've got VPC flow logs, we've got AWS CloudTrail, AWS WAF logs now, Shield, all of these things over on the far left, and those are great, and we definitely want to have those things. But now that we've detected this issue, right? We just talked about how these different domains are going to give GuardDuty the ability to let you detect these threats. What happens? What do we do? Well, that's kind of the interesting moment, right? So basically everything's going to funnel into CloudWatch. CloudWatch events is kind of the thing that we're going to talk about first. That's effectively this portion of the world that, if you had to liken it to something, it's kind of the brain, right? We're going to teach CloudWatch events to do stuff. When I see the color blue, I'm going to think sky. When I see AWS CloudTrail, let's say someone turned off CloudTrail, I'm going to think that there's a problem, and I'm going to try to do something about that. And that's kind of what CloudWatch does. It tries to make that thing happen. So we're going to go ahead and we're going to activate a step function. And why are we going to activate a step function instead of just a direct Lambda? Well, if we activate a direct Lambda, then we're only going to get the output of that one Lambda. So we're only going to see one thing. And if that Lambda doesn't fire, or if there's an unexpected consequence of that Lambda, it's going to be really hard for me to go ahead and fire another Lambda on the back of that. However, if I use step functions, I can actually programmatically and logically figure out what I want to do with that response. If it's a weird response, if it's not one that I expected, or it's something simple like, hey, that drive is being used, we can't disconnect it from the instance right now, we can program a wait time. We can figure out what we want to do until that's done. If it's something that we're not allowed to do all of a sudden because someone's changed the way that the IAM roles for that Lambda are assigned, then we can go ahead and deal with that right then and there and say, okay, we need to go ahead and send out an SNS notification immediately. Now, I'm going to point out here as we talk about SNS notifications, you'll see at the top right way up here, we have team collaboration Slack. As we talk about things that we need to do and responding to findings in GuardDuty, a really good thing to do when we're going through this is to respond immediately to our team. If we have an incident response team that's helping us with our AWS deployments and implementations, we need to make sure that that incident response team is aware of different findings that GuardDuty has. Now, that doesn't necessarily mean that we need to tell them every time that GuardDuty finds a finding, because there's a lot of findings in GuardDuty that, you know, they're kind of low level findings. Maybe there's a nation state that's pinging your server, and maybe that's a big deal, and maybe it is, and maybe you need to tell your team about that right away, and maybe you don't. But that's kind of one of the things we're going to talk about today, is planning that out and what do you need to do. But I'll point out that the first and best thing that you should do is really begin that communication process. Now, we also see EC2 Systems Manager down here, and that's kind of an interesting one. That's kind of come up recently. It's been released as its own new product by itself on the services page, and that's kind of an interesting one. So what about EC2? What about Systems Manager, and what's the difference between that and Lambda? So Systems Manager is generally referred to as SSM. Way back when, it used to actually sit on the bottom left-hand side of the EC2 menu, and you could make it do different things. And the initial thing that you could make it do was run command. And you could run a command on the console of your EC2 instance, which was really kind of neat because you didn't have to log in and do anything. So now what we're going to suggest that you do when we're looking at incident response and we're looking at this GuardDuty finding, if it's an onerous finding, if it's something that you really think is bad, well, cool. Then we're going to have to, well, not cool, but we're going to have to go ahead and respond to that. And we're going to have a step function that fires off a Lambda, and that Lambda is going to do a bunch of things on the outside of that instance. And the reason it's going to do a bunch of things on the outside of that instance is not because we can't increase the instance profile or change the instance from inside the instance, but rather because we don't want to change that instance. We don't want to have that instance be elevated or have new privileges that potentially, if that instance is indeed been compromised, that new compromised instance could begin to do bad things to the account or different things to our volumes. We want to make sure that that instance is in fact kind of quarantined. Now, we do that all through the Lambda so that we don't have to change that instance profile or give that profile new abilities. Hope that makes sense. Now, what do we do with the SSM document? Well, the SSM document actually functions inside of that instance, not on the outside of the instance like Lambda does. So the SSM document is going to begin to do things like network captures, memory dumps, process reviews, potentially, any internal tools that we've decided to develop and deploy. Now, we're going to talk a little bit about that in a minute, but effectively what we're saying is, yeah, prior to actually doing any of this stuff, you need to plan a little bit, right? We need to think about what internal stuff we want on our EC2 instances. And that means sitting down with our tools department, our IT department, and saying, hey, do you want a memory dump? Do you want a disk capture? Do you want a snapshot? Is that going to be helpful to you? That's kind of an interesting question, and one we'll get to in a little bit. So what are we going to do? Well, a lot of people, when we start this, say, well, okay, how do I turn on GuardDuty? Well, guess what? There's a button to do that. Click here. When you click here, you will immediately find yourself in the GuardDuty screen. Now, you'll note that we've got a couple of things here. We're going to look at this middle one today. We're going to look at cryptocurrency, EC2 bit mining. Uh-oh, you found it. We'll talk about the CNC bit activity as well, maybe, but we'll get to that in a minute. For right now, we're just going to focus on this first finding, okay? So we've turned on GuardDuty, and we found that we've got a finding in here, and that's interesting. What are we going to do? We have to remediate this, and we need to remediate this now. So let's go ahead and write a Lambda action to do that. So maybe we're going to want to go ahead and reset some account passwords, right? Somebody obviously had an account breach if this instance suddenly has crypto mining software on it, right? I mean, that has to happen. And then we're going to go ahead and we're going to remove this instance maybe. And there's a lot of things we could do here. And your internal management and legal department is no longer happy with you. I'm going to point out that if you start going down the road of Lambda remediation for anything, crypto mining or anything else, pretty shortly you're going to have a really unhappy manager. And why is that? Because you didn't plan out what needs to happen. So let's take a moment and plan correctly. So runbooks. I know this is everyone who's ever done IT's favorite word. I know that it's been my bane of existence for 20 years, but the reality is that this is a really good way to deal with instance issues. And to be fair, when we talk about threat detection and auto remediation, you're basically writing, I'm sorry to say, but you're writing user stories. I mean, if you guys do agile development in your enterprise, this is a really quick and easy way to write the user stories that you need to write to get to being able to automatically remediate instances once they've been noticed as having an issue inside of GuardDuty. So what do we need to think about when writing runbooks? So we're going to start doing some pretty massive things to our account. First thing we need to think about, We need to think about attribution. Do we care about catching the individual or knowing what caused the incident? In some cases, we care about who did it. In some cases, we just care about what did it or why it broke. And we need to ask our legal department what they think is important for us to do. Some folks on the phone or on the webinar are going to be HIPAA compliant. They need to do different things. They need to understand what data has been leaked, right? We need to understand if the information surrounding this incident needs to go to a third party. Do you guys have a third party that needs to actually do something? Is there PR that needs to go out? We need to understand if you guys want to do, if your enterprise actually wants to do forensics. If they do want to do forensics and you have a third party that needs to do forensics, how do they want to do it? Do they have tools that they need to do? Do they have data that they want you to collect? You need to understand what timed procedures are being run. So if there's an end of month closing of your accounting books, you want to make really sure that you are not auto-remediating the instances because they're using a whole bunch of CPU and having different people connect to them. And you know what? We thought it was somebody hacking the accounting machine, and really they were just running end of month book closing. That would be really a horrible moment to be in. And once you do that, it's going to be really hard to continue with this process because people are going to be scared of it. So better to sit down to begin with and start looking at this. Okay, so those are our ground rules. Just as a side note, please do these things before you actually start doing this. And what does a run book look like, I guess, is the next question. Well, this is a general run book. It's just a couple of different steps to think about as we're going through this, right? We've got to have a description of problem. Why do we have to have a description of problem? Because we need to be able to have the individual running our operations department understand what this particular problem and solution is going to be, right? Now, old school, if we were sitting in a data center, you'd need this to be a description that they could actually go to their monitors and check and validate that they now have this problem. So in this case, what are we going to look at? Well, we're going to look at some different things that are going to show us how do we figure out what this problem is? What did CloudTrail tell us? What did GuardDuty tell us that helps us understand this, right? And then we need to figure out how to fix it. And this is really our user story, right? So the beginning of it's kind of the story definition. The second is the steps. So that's kind of the things that we need to do in our user story, the functionality that we need to create. And I'm going to point out that urgency is kind of an issue here. We need to make sure that we're clear on what the urgency for this particular finding is going to be. Do we care? And to be fair, maybe your company mines cryptocurrency in AWS, and if you find cryptocurrency, it is informational only because that's what you do. Maybe not, who knows? Escalation path. This is an important one. I added this in here kind of, I've got the CEO there at the bottom because it's more of a gag, but realistically, if you think about it, I mean, let's be honest, you need to have a list of people that need to be told, and you need to think about that now as opposed to at the very end. So this is one of the things that you need to get out of the groups that you just talked to on the last slide. So how do we figure out what to do in the runbooks? Well, once you activated GuardDuty, you've got this wonderful little button under settings up there on the left, and then down there, generate sample findings. And what does that do for you? Well, generating sample findings does this. You have all sorts of cool findings that you can actually see, right? And that's pretty neat. So now, if we need to build a runbook, we've literally got 42 samples of information that allow us to begin to build our runbook. And with those 42 samples, we can start to actually build out our automation routines as well. And I say that because once you click on that, and we're going to go into this now, we're going to get a couple of things out of it. We're going to have a JSON item that we can open up and play with. So as we look at it, we're going to see a type, and that finding type is going to be cryptocurrency, EC2 Bitcoin tool DNS. Oh no! And we're going to get an instance ID. So with these two items, we now know that this particular instance is indeed compromised and is starting to Bitcoin mine. That's an important thing to know. So if I'm writing code, those are two variables that I'm going to want to have, right? Well, in my runbook, I want to make sure that my problem description reads thusly. Now, I've taken this as literally copy and paste from the GuardDuty findings definitions, so please feel free to do that if you'd like. I think that's a great way to start the problem definition. Obviously, this is the cryptocurrency DNS entry. Cool. Data to gather for troubleshooting. Now, I've added account ID because let's be honest, if you've got something like this going on, you probably want to know the user that was responsible for this too. Now, that might be in a tag, that might be somewhere else. There's all sorts of questions associated with this. For this one, to keep things simple, we're just going to focus on the instance ID, but there's some other things surrounding this that might also be interesting to you. So as we look at this instance ID, I want to know the subnet. I want to know the VPC ID. So why do I want to know that? Because I want to be able to validate the connection that this system has to other systems. I might want to look at the endpoints. If it has access to our S3 endpoint, does it have access to a specific bucket that I need to make sure has it looked at that data yet or not? And I want to know that because let's say that I'm a HIPAA regulated company. I need to know if anybody's viewed data that they shouldn't have viewed, and I need to know if I need to go ahead and clean up that data spill. All right. After this, well, now we've got something, right? Now we've got steps that we need to troubleshoot and fix. So we're going to notify our IR on-call team. Now, I should point out, these are 5 things that I personally put together. This is not 5 things that I'm suggesting that you go do all the time or doctrine of any kind. This is me giving some general advice as I look at this particular one, things that I would do maybe if this were my company. So notifying the IR team on call. Cool, gotta tell people what's going on. If I don't start telling people that there's an auto remediation system running and they come and look at my AWS account and they see a Lambda functioning, maybe quarantining instances or deleting them, maybe they'd freak out. So let's go ahead and tell people that something's going to be happening. Cool, absolutely. So we're gonna run an automated instance quarantine. Cool, that means that that instance is no longer going to be able to get to anything else that was on that subnet or connected to those endpoints, right? I'm gonna go ahead, if it were me, and take a snapshot of that instance and make sure that I get the VPC flow logs to the forensics account. Now, by forensics account, one of the things that your SA should talk to you about is a multi-account setup. So one of the things that is gonna come out of all of this is the fact that you probably ought to have a couple of accounts laying around that your auto remediation systems can dump things to. And why do we do that? Well, let's be honest, if we have a corrupted instance or we have a compromised instance, chances are the data on that instance is not something I want one of my administrators accidentally fumbling into. I want it to be somewhere away from everything else so that if it compromises anything, I don't care, right? And beyond that, if I have a third party coming in to help me with forensics, I want that third party to be able to access that data in a place that's not my production environment, because let's be honest, mistakes suck. And if you make a mistake in a production environment, it's never a good thing. So do it in a forensics account. And finally, we're going to validate that whatever new ASG created instance is working correctly. So I want to get a green light at the end of this and make sure that, hey, everybody's good, right? I think that's a pretty solid thing to do. So what am I going to code? Well, I'm going to go ahead and code a CloudWatch filter to trap the instance. And I'm going to look at that specific instance type, right? Now, that doesn't mean that that's the only thing that I can look at. It just means that in this case, I'm going to do an event with just this particular thing here. Now I'm going to do that specifically because this is kind of the easy thing to do. And I should point out that no, we're not going to open up a code. We're not going to open up any code systems or do any of the code today. That's really not what this talk is about. The talk is really about telling you how to do this. We're actually going to do a Twitch here pretty shortly on doing a lot of this stuff. And we'll go through the actual line by line of how to pull this off. But it would take another half an hour to do it. And to be fair, if I did a demo of it, it really happens in about half a second and isn't interesting. So we're going to talk about it and we're going to move on, and I'm going to show you a way to do a second one as well so that we have 2 different findings, and hopefully this is helpful to you. So as we go through this, we're going to look at the SNS that's going to fire. Have to do that, right? We've filtered, and now we're actually going to start doing this function list. So these are the things that my step function is going to begin doing. We're going to fire some SNS. We're going to look at the Lambda function that's going to run some SSM things inside of that instance if we wanted to do anything about processes or trying to diagnose which crypto mining software it was. And then once we realize that this Lambda is finished, then we're going to go ahead and quarantine the instance. Done. Now, again, keep in mind that Lambda functions on the outside of the instance, SSM functions on the inside of the instance. We want to make sure that when we're done, the Lambda cuts off all the network connectivity to it and removes all the volumes and make sure that those volumes and everything else is over in the instance in the forensics account. And you'll note that's kind of what happens on C, right? We're going to make a snapshot, the final snapshot of this whole thing. And then what I didn't say here, frankly, is we're going to take this snapshot and we're going to shove it over to that forensics account, and we're going to burn the snapshot from the primary production account again, because we don't want things to happen in that production account that we weren't expecting, right? Then we're going to make sure that step function says agreed, that everybody's happy and there's nothing else that we need to do. And then we're going to fire one more Lambda that's going to stop and destroy the instance. Boom, gone, right? Now at this point, we would assume that our auto scaling group is going to spin up a new instance, right? And once we've done that, we should actually go ahead and get a really nice green light and everything should happen well. So why are we going to talk about escalation path? When are we going to talk about escalation path? You'll note in the code that I wrote, right, there was only one SNS sent. If we're doing a Slack SNS or something along those lines, we may actually want to wait for different things to come back. And depending on how we do this, we may actually want to wait for different messages to come back in different channels. So to be fair, it may be the type of thing where we send out the SNS over here, right? We send out that SNS and we hang and we just wait. And when you tell me to go, then I'm going to go ahead and run again. And then if nobody tells me to do anything after 5 minutes, maybe I go to somebody else. Maybe I go to a different SNS list and try to find somebody else, distribution list and a la forever. Okay, cool. So items to code. Now I'm going to tell you right now, like I said, we're going to go to Twitch. Different things that you can do. We've got security automation there, and I put the link there in the PowerPoint, and you've got the GitHub Labs. Now there's a couple of things we'll talk about at the very end of this, but great places to go, good sources of information. All of the code that I would have written for you and will write for you later will also be there, so you're good there. All right, so what else? What's another one that we can do? Well, we've got unauthorized access. Oh no! Right now we've got a different network coming and accessing our stuff, and that's just even worse. Okay, so what do? Well, we go back to the sample findings place, right? And we get the XML for this one. Cool, this is a little different, right? We don't have an instance that's been accessed. We've actually got an account that's been accessed. And I picked this one specifically because it is an account, right? It's two very different things. The first one was very much infrastructure, right? The second one is very much services and account. So as we look at these two things, it's really two kind of sides of the same thing, and we've got application there in the middle. So as we start, taking this thing apart, admittedly, JSON is not pretty to read, but we can see the type right there at the top, just like the other finding, right? We see unusual ASN caller, not normal. We're not used to seeing this, and we've got the finding username, so we know which IAM person that this actually is. Once we do that, what's this going to look like? Well, we've got it right here. We went to the GuardDuty findings screen. We copied the definition, the description of that, right? We got the username, and we know that as we do this, these are the things that we're going to want to look at. So one of the things that we're going to look at here that's different is probably we're going to want to look at CloudTrail and decide what actions has that user actually taken. I want to know what has that person done? Has he made any other users? Has he made any security groups? Has he made any instances? Generally, when I see this, and we'll get to this at the very, very end here, we see this because somebody's done something, and we'll talk about that in a minute, but we will see people spinning up instances or making new users. So how is this different beyond that, though? Well, a lot of this then steps to troubleshoot. Again, we need to notify the IR call team. We need to rotate user credentials and terminate active sessions. So pretty straightforward stuff, right? I mean, there's nothing here that tells me that there's something horribly hard to do here. It's relatively easy to logically think through. And I'll point out right now, it's really easy to logically think through now because it's not actually happening. This is the time to logically think it through. Go back to that sample finding screen, think it through now as opposed to later. Talk to the people in your company now as opposed to the morning that it's happened and you have to figure it out. Okay, so what are we gonna code? We're gonna do a filter with a different type now. So now that we've done a filter once, we're gonna do a filter again, same thing, different string, right? And we're gonna fire a step function again. We're gonna fire off the same SNS topic. So to be fair, pretty similar stuff, right? The only difference here is we're gonna start rotating keys and user passwords. So we're gonna look at which user was used and we're gonna rotate that user's passwords. Maybe we're gonna just go ahead and revoke their keys entirely. We're gonna go ahead and revoke any sessions that they have active. And then we're gonna go ahead and write a Lambda to go ahead and look at CloudTrail and see any actions taken by this user or instances touched by this user, right? This is something that we need to make sure that we do. Okay. One of the things that comes up here is, well, can we actually begin to remove some of these instances or users or whatever this person has done automatically? And the answer is sure. But I want to make sure, again, you go back and talk to your teams that you need to, back to the suggestion slide. Okay, so escalation path, pretty much exactly the same, right? We're going to do the same SNS kind of thought where we're going to probably post to some sort of a topic. We're gonna look at maybe a different distribution list, maybe a different distribution list if individuals are getting to respond to this, but effectively it's the exact same stuff. So final thoughts as we get done with this. Both of these hit this little matrix here, right? Service disruption, persistence. What were they, do you think? Which ones do you think they were? Well, if we think about this from a prevention versus reaction point of view, right? We want to make sure that we get all of the pieces, parts that actually happened. We don't want to just say, oh, well, this was, the first one was compliance variance because you really shouldn't have cryptocurrency mining. The second one was, well, maybe that was privileged escalation or unauthorized access. It was one of those two. Maybe, but I would actually argue that both of them were these three items. So both of them were a compliance variance. You shouldn't be able to access the system from an outside system that you weren't expecting to, right? But also you shouldn't be able to install cryptocurrency mining software either. And in either case, whoever did this, that individual actually had excessive permissions. We weren't using the least privileged model. And in both cases, unauthorized access has occurred. So what does that tell us? Well, that tells us we probably ought to look at prevention versus reaction, right? We don't want to do this morning of, because if we do this morning of, maybe we only see compliance variance and we miss the fact that the other two items were there as well. So how do we do this? How do we think about this going forward? Well, I'm going to suggest that we have a lot of partners to help you with that. All of these partners are wonderful people. They all do really good work. I've worked with a lot of them personally. I can speak to a number of folks at many of these companies and to the great help that they've been to me in different security needs that I've had with multiple clients over the years. So good things to talk about. Reviewing the issues that occurred. Let's close the loop. What do we do? Well, let's be honest. I mean, most of the stuff that I see, and I'm one of the individuals that gets to talk to customers once they've had a bad day, right? I get to go see them when something bad has happened on their account. Do you know what I see most often? I see most often customers posting some of their secret keys to Git. And so I'm going to call out Git secrets and ECS secrets. These will help you keep your secrets out of Git. And that's a really, really good thing to do. Don't post your AWS secrets to Git. Please use SSM parameter store. Really a good thing to put stuff into. AWS Scout 2, also a good thing to do, not an AWS product, but solid stuff. This is one of those things that you can run on your account and it'll give you a review of things that you ought to look at in your account. Again, prevention versus reaction. So as we go forward, what did we learn? Least permissions. Please, please, please always do least permissions. Make sure that that goes into everything. Profiles are key. Why are profiles key? Because they affect so many things. Your Lambda functions have a profile, containers have, you get the point. Roles, users. I'm going to suggest that realistically, you probably shouldn't have users in your production environments unless you have break glass users. And that's one of those things, totally up to you. Least privilege on everything, please. All right, DevSecOps. If you have a production environment and you're using AWS, I would love to see DevSecOps in everything you do. Why? Because it makes threat detection so much easier. It means no humans are in your environment, your production environment, and it lets us find stuff in that environment very, very quickly. Keep the humans away from the data at all costs. Humans make mistakes. We are the mistake waiting to happen. Production is set apart. Always keep production outside of human control. And the pipeline is no human zone. So that means that basically I'm going to build a pipeline, I'm going to deploy that pipeline, and no one ever logs into that pipeline again until they need to make a choice. And realistically, that ought to be a redeployment, not a manual change. Okay, so what do we need to take out of this? GuardDuty plus planning, runbooks times SIRS times partners equals more sleep. This is a pattern that I completely believe in. I love sleep as an old operations guy. This is really one of the things that I really love. Always notify people, always tell people what's going on. Make sure that you know what the DR goals are. Always do runbooks. It's an old practice. I mean, we're talking about way back in the 70s, folks. It's been around for a long time, and there's a reason. It's a pain in the butt, but it's a good thing to do. So call to action, enable GuardDuty. The first 30 days are free. Assets assess after 30 days. Chances are you're going to spend less money than you would have expected on GuardDuty. It is one of the cheaper services that you can enable. You will have 30 days free to figure out how much it's going to cost you. I know on my private account, I get less than 5 cents a month on it. So it's up to you guys. I would turn on GuardDuty. I think it's a really good choice. And that's it.